Recurring decimals. You'll either be asked to write a recurring decimal as a fraction, or prove that it's a fraction given. First of all, we're going to have 6 examples, and our first one is going to be 0.7 recurring as a fraction. So let's make x equal to 0.7 recurring. And I'm going to write out here what the decimal is actually doing. My aim is to cancel out the recurring decimal part. So I'm going to multiply this by 10 to make it 7.7 recurring. Now, if I take away 0.7 recurring from 7.7 recurring, it will all cancel out, leaving me with just 7. If I've taken the x away from the 10x, that will give me 9x. So 9x will be equal to 7. And if I rearrange this, x will be equal to 7 over 9. Example 2. Write 0.29 all recurring as a fraction. So I always start by making this equal to x. So x equals 0.29 all recurring. I want to cancel out this bit, so this time I'm going to have to move this 2 columns. So I need to multiply it by 100 to make 29.29 all recurring. So now you can see that these will cancel if I take one away from the other, leaving me with 29. So 99x will equal 29. And if I rearrange this, x will be equal to 29 over 99. Example 3. Write 0.813 all recurring as a fraction. So again, let's make it equal to x. And as you can see, I have the 0.813, 813, 813 here. I'm going to need to move it 3 columns so that I can cancel it out. So let's multiply it by 1000. 1000x will give me 813.813 all recurring. So now you can see they're nicely lined up, so they'll cancel out, leaving me with 813. And if I take away x from 1000x, that will give me 999x is equal to 813, which if I rearrange, x is equal to 813 over 999. Right, let's do 3 more examples that are a little bit more difficult. This time, write 0.37 recurring as a fraction. As always, x is equal to 0.37 recurring. And this is where writing it out like this may be more helpful. I need to get rid of this 3. It's in my way. So first of all, I'm going to multiply it by 10 to give me 3.77 recurring. And now I can cancel this bit out. I need to move it across again, so let's multiply it by 100, so 100x is 37.777 recurring. Now, if I take away the 3.7 recurring away from the 37.7 recurring, it will cancel out. But this time I've taken 10x away from 100x. So 90x will equal 34, which if I rearrange, x will be equal to 34 over 90. Obviously they both have a factor of 2, so this will cancel down to 17 over 45. Example 4. Write 0.649 recurring as a fraction. Again, x is equal to 0.649 recurring. Now, I need to get down to just this 99999 bit, so I'm going to multiply it by 100. So 100x is equal to 64.9 recurring. This leaves me the recurring bit. If I multiply it by 1000, that will give me 649.9 recurring. I can now take these away from one another to get rid of this bit. So 649 take away 64, and then I've obviously got 1000x take away 100x. So that leaves me with 900x is equal to 595, which if I rearrange, x is equal to 595 over 900, and this will cancel down to 19 over 180. Right, our last example. Write 0.745 recurring as a fraction. Start off with x is equal to 0.745 recurring. This is a helpful bit here. I need to move this across. Now, I actually want to make the 45 bit, the recurring bit on the side. So I'm going to multiply it by 10, so that I've got the 454545 after the decimal. But to get this so it all lines up, I now need to multiply it by 1000 which gives me 745.45 recurring. So now I have the 45454545 lining up. So when I take it away, it will all cancel out. So 745 take away 7 and 1000 take away 10. That will give me 990x equals 738, which if I rearrange, x will equal to 738 over 990, which cancels down to 41 over 55. Because we always deal with either x, 10x, or 100x, or 1000x, it will always be over either 999, 999, 900, 990, something that contains 9s. If they ask you to prove the fraction given, and the fraction isn't over something like 990 or 900, then it's being cancelled first, so do watch for that.